Imagine you open up your math book and see a problem with numbers, fractions, variables, and it looks like a total mess. You think, multi-step equations? No way, I'm never getting this. But here's the secret. Every complicated equation can be untangled with simple recipe. Today, I'll show you how to break down the chaos into 6 clear steps that work every time. Whether the equation has fractions, parentheses, or variables on both sides. I'll even share the most common traps to avoid so you don't get stuck where most people do. By the end of this video, you'll turn those so-called impossible problems into easy wins. Ready to make multi-step equations simple and maybe even fun? Let's get started. My name is Mahmoud Kiasari. Welcome to Special K. For this question, we do have fractions and LCD side by side. As I just told you, the very first thing that we have to do when we deal with fractions is we have to get rid of both of them at the same times, right? So at this point, I do have the easy one. X over 4 plus 3 over 2 is equals to 7. So obviously, the LCD or the least common denominator of 4 and 2 is just the 4 itself. So it means that I have to multiply both sides by the 4 itself. So as you can see over here, we just explained it why that LCD is 4. So right now, I have to multiply the left side by 4, right side by 4. So if I do that one, 4 should be multiplied by x over 4. You know, 4 and 4 are going to cancel each other, so we do have x. And also 4 should be multiplied by 3 over 2. So 4 times 3 over 2, it means that 4 times 3, 12 divided by 2 is 6. So x plus 6 is equals to what? 7 times 4 itself. So I do have 28. So at the end, I do have something like this. So I know how to do that. It means that I have to keep my variable in one side and move all of the numbers into another side. So at the end, I do have subtracted by 6, subtracted by 6. X is 26, subtracted by 6 is 22. If I want to check that one, I have to use it on the left side of expression. We call it as LHS. And on the right side of expression, RHS, to make sure that both of them are right. So it means that our answer is right itself. So what would happen if we do have, as I just told you, if I do have some kind of variable at this, some kind of, a fraction would be beside my variable itself, and everything would be like this. So instead of just having like that, their writing could be a little bit confusing. We do have it as x over 3 subtracted by 1 over 2 times x minus 6 is equals to 4 itself. So what is the common denominator over here? The least common denominator is between 3 and 2, right? Again, it's 6. It means that I have to multiply both sides by the 6 itself. So I do have as this. So if I just multiply both sides by 6 itself, what do I have? I do have the 6 over here, and I do have 6 over here. 6, it means that 6 should be multiplied by the first part. I do have it as 2x, and 6 should be multiplied by this part itself. So if I do that, actually I do have subtracted by 3 times x minus 6 is equals to 24. Why do I have it at 3? Because we know 6 multiplied by 1 over 2 is actually 6 over 2. We do have it at 3 itself. So I do have it as this. Again, I have to use the PEMDAS, or we can call it as distributive method. So 3 times x, 3 times negative 6, be careful about the negative sign. So I do have 2x subtracted by 3x. At this point, I do have negative 3 times negative 6 itself. So what do I have? I do have negative 3 times negative 6, 18 is equals to 24. Adding the like terms, so negative x plus 18 is equals to 24. Is that right? So it means that I have to move I have to move my number, which is the 18 itself, to the next side. And after that, negative this one should move to this one. I have to subtract it by 18, subtracted by 18, inverse operation. Negative x is equals to what? Is equals to 6. And since I'm looking for x should be, everything should be divided by negative 1, divided by negative 1. I do have it x as negative 6. So these were the 3 steps that we have at the beginning, and after that we do have 2 last steps. So we do have x as negative 6. Again, for the sanity check, we have to use x for both sides to make sure that both of them are right. So you can see, if you try negative 6 at this point, at this expression, you can see the left side and right side, both of them would be 4 itself. I mean, right side is already 4, so the left side would be 4 itself. What about the situation that we do have some kind of exceptional condition? It means that I have to consider a domain. If you remember, that domain means that what are the prohibited numbers that we do have for x itself. So at this point, I do have this equation. I just rewrite it down for you in order to better see what's going on. But just before writing it down, as you can see, I did one basic step. What was that? Move all of the numbers into another side. In order to do that, I subtract both sides by 3 itself. So I do have 2 over x minus 1 is equal to 7 subtracted by 3, which is 4. So the very first thing that I have to decide is about x actually cannot be equal to 1. This is the unequal sign. So for sure I know that since my x minus 1, as at the very beginning was over the denominator, for sure x cannot be 1 itself. So after that I can solve the equation. How I can do that? I have to multiply both sides by what? I have to multiply both sides by x both sides by x minus 1 itself. There's no common denominator here. The only thing that we do have is x minus 1. So it means that multiply this side by x minus 1, multiply this one by x minus 1. If you do that one, 2 over x minus 1 times x minus 1, let me just write it down a little bit better, is equals 4 times x minus 1 itself. This part and this part, or this term and this term, can cancel out each other. Why? Because they're completely the same. They can be considered as two numbers. For example, we do have it as 2 and 2, 3 and 3, right? They can cancel out each other. So at the end, what do I have? 2 is equals 4 times x minus 1. So after that, it would be easy. Distributive method, 4 times x, 4 times negative 1. I do have 2 is equals 4x minus 4. So in order to solve that one, I have to make sure that everything would be on one side, all of the numbers I mean. So I have to add both sides by 4 plus 4 plus 4. I'd have 6 is equals to 4x, and at the end, x is equals 6 divided by 4, which is 1.5. In order to make sure that that number is right, the only thing that I have to do, put that 1.5, put that the 1.5 at the equation itself to make sure the left side of equation and right side of equation are going to be the same itself. So let's talk about some of the traps that we have to avoid, because as I just told you, the recipe is okay as long as I follow it completely without any problem. But what would happen if I do a couple of things that going to some kind of lead me to the thing that I want? The very first thing that we have to do is that sometimes we forget to multiply every times by the LCD itself. As I just told you, the LCD is there in order to help me get rid of fraction, right? And I also have to make sure that when I'm talking about the LCD, for example, when I'm talking about the time, I have to multiply 12 by everything because I want to get rid of a fraction on the left side. Sometimes it would happen for some students that they forget to do that on the right side. Why? Because again, we are talking about the balance. We are talking about the situation that we don't change anything. If you add something into one side, you have to make sure to add it in another side. Multiply by one side, multiply by another side, and etc. So this is a very common mistake. Another mistake that could happen is about the sign. As I just told you in the previous module, the sign is going to be important in the equation, and also more important when you have inequalities, because for inequalities it could change or flip the symbols or the signs, that flip the smaller than or bigger than, and you have to make sure you completely follow the path and follow the rule to find the right answer. About the equations, it's not that kind of challenging. The only thing that you have to know are 4 rules. Some kind of positive times positive or divided by positive, doesn't matter, is going to be positive. Positive times negative and negative times positive, both of them are negative, and negative times negative is actually going to be positive. Sometimes when you multiply numbers, especially a negative by positive, it could happen that you forget about the sign. That's why we do have the sanity check. We have to reevaluate our answer to make sure when we put it into the expression itself, make sure that the equation is going to be equal from the left side to the right side itself. Another one that they do have is about dropping the parentheses. So try to remember that at the beginning of the point, get rid of parentheses because it's going to help you. And also at some points, make sure that when you're trying to follow up this or apply this rule, 2 should be times x and 2 should be times negative 3. So I do have it as 2x minus 6, not 2x minus 3. It's very common. Try to ignore that. And also another thing that we do have as ignoring domain is that when variables appear in denominator, as I just told you, we have to consider the fact that we need not any condition. I can have a fraction that its denominator is going to be 0. So whenever I found, for instance, x as is equals to 3, in the meantime, I know I do have a fraction that this is something like this. For sure, the 3 is not going to be the answer because it doesn't matter if x is equal to 3 is going to be my final answer. I cannot put it over here because at the end, I'm going to face some kind of problem itself. And another part that we do have itself would be about skipping the check itself. What is that? It's skipping the check. as you just remember, is if I just told you that all the time try to substitute your answer back into the original equation to verify it works. It means that when you some kind of find the number, for example, x is equals to 3, you have to also make sure that you put x3 into both sides of the equation and make sure that everything is going to be right itself. So these are very, very common mistakes that you will see sometimes in your equations, and you have to make sure that you're not going to fall in any of these traps itself. So that was the very last part of our some kind of module itself. We were talking about the equation, how we can solve it, and what are the 6-step recipe that we are going to use, what are the things that we have to avoid. And for the next module, we are going to solve a couple of questions to solidify everything and make sure that you completely understand this concept itself. So please like, share, and comment if you like that one. And also don't forget to subscribe to this channel itself. My name is Mahmoud Kiosari. Have yourself a great day, night, whatever. See you around.